Okay, hello everyone. Welcome to this HashiConf lightning talk. I'm really glad to be here, and at the same time really excited about all the really good announcements that HashiConf is doing on this conference. So it's really good. We are at quarter to an hour, so let's get it started. We are limited with time, so this is only a 15 minutes talk. Let me start by sharing my screen. So here we go. As I said, welcome everyone. This is a lightning talk about how to automate your Terraform Cloud. If this is not a talk you're here for, it's worth staying anyway. I think it will be quite exciting and interesting. I do have a couple of slides, but it will be mostly kind of a deep dive into how to achieve that and kind of try to demo different one of the options, not different options, but one of the options that you can achieve that actually. So if you do have any questions, please just drop them in the chat box or in the Q&A section. I will try to finish a couple of minutes before this lightning talk ends, so I will be happy to answer questions there. Or otherwise, please don't hesitate to reach me throughout the social media, and I'm happy to answer via that channel as well. So first, let me start with who am I? So I work as a senior IT consultant at the Scale Factory. We are a DevOps consultancy that are also AWS Advanced Consulting Partners and Kubernetes service providers. Even though we are based in London, we do have a first remote policy, so most of my colleagues are scattered around UK. And I have a really rich kind of ops background, so I come from IT system management design and extensive Linux and virtualization experience. And I'm really passionate about open source. I'm an active contributor and supporter. And when I'm not doing any of the previously mentioned things, you can find me hiking, cycling, and traveling, which is unfortunately not happening that much lately due to the global situation nowadays. So without further ado, let's kick it off now. So first of all, I would just like to kind of slightly stop at the Terraform Cloud. Let's quickly have a look what it is and what we can use it for. So in a nutshell, Terraform Cloud is a SaaS solution offering from HashiCorp. It was used to be known as Terraform Enterprise. There is a separate Terraform Enterprise on-prem that you can host yourselves, but originally Terraform Cloud is a SaaS solution that you can use out in the box that offers many of the functionalities as standard Terraform. So you can express your infrastructure as a code in a kind of a simple human readable language, which is called HashiCorp configuration language version 2 right now. And it kind of works in a two-phase planning, where you have first phase called planning, where you kind of get your speculative plan for a review, and then you can apply your changes and reflect your expressed infrastructure as a code into your real infrastructure. It does offer an extensive set of providers and modules, and most importantly, it offers a self-service infrastructure as a code. So beyond using just Terraform, the Terraform Cloud actually offers that you can run your Terraform in the cloud and use things like private module registries. So you're not just bound to the public registry or publicly accessible Git repos. You can also use a public module registry, which we'll see how to do that in a demo later on. And it offers, I think, one of the probably strongest points of Terraform Cloud is definitely managing of the state file and locking. So when you're working in your team with your colleagues, you can actually safely store your state in a SaaS solution where it's safely stored and locked to prevent unsafe parallel execution. It can have different modes of execution. So like I mentioned, you can have your Terraform executed in Terraform Cloud or locally. And it does actually support multiple providers where you can apply your code, for example, like we see in the picture right here, either in Google Cloud, Amazon, or Azure, or any kind of other cloud provider. It does offer a multi-cloud compliance, so you're not strictly bound to a single cloud provider there. Okay, now let's have a quick look at a Terraform Cloud environment. So as I mentioned before, it's a cloud environment where you can run Terraform. It kind of encapsulates your workspaces where you define your execution environment and define execution mode, versioning, variables like VCS, providers, triggers, and notifications. And more specifically, what we are interested in today is how we can actually manage that remotely, right? Or like how we can actually automate that. So firstly, if you look at Terraform Cloud, it has 3 workflows for managing your Terraform runs. So first, the primary mode of operation is UI or versioning control system driven. That means that all of your executions are tracked in the system and are easily triggered and controlled throughout your versioning control system, like GitHub, GitLab, or Bitbucket. If you opt out for the remote execution, you can still have a second kind of option for your workflow. So CLI driven. It uses Terraform standard CLI tools to execute runs in Terraform Cloud. So it means that Terraform Cloud is only used for your remote storage safekeeping and locking, but the Terraform runs are executed locally and the workflow actually looks exactly the same as you are used to before you decided to go to Terraform Cloud actually. And the third kind of workflow that it also supports is so-called API driven. So additionally to the kind of streamlined offerings, it offers the public API that you can actually use. It's definitely more flexible, but at the same time, it requires some glue there. So you would need to develop some tooling around how you would actually apply your changes and how would you react to the versioning control system changes, right? So the question that really kind of poses us here is, can we actually automate that itself? So besides having your infrastructure deployed from Terraform, can we actually use Terraform to provision our Terraform Cloud configurations? So in order to answer that question, the simple answer here would be yes, of course. There is a so-called TFE Provider. So it's an upstream HashiCorp managed provider, usually originally developed for Terraform Enterprise. In this code snippet, we can see that we can just grab it from the HashiCorp namespace. And the latest version that is out there is 0.21.0. It doesn't take any additional configuration. You can just use it, and it does provide a very rich set of resources you can actually use and configure. You can actually configure almost anything. The only things that you cannot kind of trigger from the provider is actually Terraform runs and executions. But that is usually kind of driven throughout the version control system triggers anyway. Okay, we reached the time for demo. So let me just quickly switch to my terminal here. So as I promised, so this will be mostly kind of a hands-on experience. So if we quickly inspect my test repo here, what do we have here? You can see that beyond the obvious README file, we do have a Terraform folder where we have our cloud configuration stored. So there's a subfolder called cloud where we're gonna trigger our cloud configuration from. And then I have also defined a couple of very simple Terraform configurations we're going to execute when we define the Terraform Cloud workspaces on it. So before we look into detail, let me quickly switch to my Terraform Cloud organization. So this is my demo organization. And the first thing I would like to kind of show you is I have defined a private module, a module in my private module repository here. So as I mentioned before, without going into detail what that module does, the important thing that I would like us to focus now is we're going to use a couple of Terraform enterprise resources for configuring our Terraform workspace and settings within it. So as you can see here, we're going to use resources for setting notifications, run triggers, variables, and of course the Terraform workspace itself. The inputs we have to use here are actually OAuth token for setting up VCS configuration, the organization name, and of course the VCS organization and VCS repository that is going to be used for all the workspaces we're going to provision. So before we look into the code, let's quickly look at the TFE workspace I have created. So I pre-created this one. Obviously, if we would just run the Terraform initially, it will be automatically created, but I already created this one specifically for the reasons that I'm not losing my time entering my secrets. So as you can see here, I have defined a couple of Terraform variables for my workspace here. I'm going to show you how it's that used later on. The important thing here is that we are also defining an environmental variable TFE token, which is a Terraform enterprise token that you would need to use in order to use the Terraform enterprise provider and configure your Terraform workspaces within your Terraform Cloud here. The second thing I wanted to show you here is in general configurations of configuration of that workspace, I have set the remote execution. So this will be completely executed on the remote side. And I will be kind of working within the Terraform/cloud working directory. And this was already linked to my GitHub repo that I will show you just in a bit. So before we go any further, let me quickly switch back to my console here. And let me show you how my Terraform Cloud Terraform, sounds really funny when you kind of say it out loud, looks like. So as I mentioned before, I do have a Terraform module that I defined. It kind of consolidates all the functionality. We won't go into detail here, but what it actually does is it will set up the organization token and the VCS configuration here, and I will pass the variables you have seen there to all my workspaces that will be provisioned from here. And we are also provisioning, besides workspaces, we can also provision triggers and Slack notifications. So let me quickly create a workspace here. So what we're going to do is I'm just going to quickly create a test workspace here that will use my Terraform/test folder there. And if we quickly commit that in, just going to say add test. Just quickly commit it in because we're brave, we're committing to master. And what should happen just in a bit, you're going to notice that when this one refreshes, see, the Terraform workspace has been triggered. And if we inspect what's happening here, we're going to see that it's trying to create a new workspace, and it will automatically pass our variables into the new workspace, in this case, AWS secrets keys and access keys. And it will also set up the basic configuration of the repo. So let's just quickly go and apply that now. And as we go out there, you're going to see as this one is applying, just in a bit, as soon as it applies, you're going to see there is a new workspace that we define through our Terraform code that is already planning, which is when you programmatically create this one, it will automatically trigger the planning phase. And as you can notice, it will automatically plan my code from that repo, which we can go ahead and confirm. And in this case, it will just create an S3 bucket without any additional settings there on it. And just to kind of show you, the bucket is not here. And if I refresh that after the apply phase, I'm really sorry for that. Just going to quickly go logging back to the my console. So if you go here, you're going to notice that there was a backend created driven civet, and it was triggered automatically from the workspace that we have programmatically created. So quickly going back here, I think, yeah, we are just on time actually. So this concludes our quick presentation on how can you configure your Terraform Cloud workspaces programmatically using Terraform. And let me quickly look if there are any questions on the chat. Okay. Yeah. Thanks, Frank. Yeah. I'm happy to stick around for a couple of minutes if there are any questions or anything you would like to discuss. Otherwise, really enjoy the rest of your HashiConf, and please keep in touch.